So we're recording. Can you just simply describe what you see of the egg into the camera without dropping it? Be careful.
Well, I see it's like really squishy. The yolk, you're able to see the yolk just flowing around in there. I dropped it.
Oh no. Okay, that's okay. All right. So we have no, because that's mass.
All
All right. Don't
What do you
drop
mean,
the egg. All that water is the mass of the egg.
Oh.
Okay. So I'm going to come back, and you're going to try and scoop up as much of that as you can into there. Okay. I'll come back.
That's fine.
All right. Is there any fructose in the water?
No.
No. Okay. So no fructose in the water. All right. So we'll have a. It's okay. Fail. Do not drop eggs. Okay. So here's the video. All right. I would like for you to. You don't have to be in it, but you need to show the egg and talk about the egg. What you notice about the egg. Okay. Okay. So talk about the egg in comparison to the other egg that you saw.
You talk. You chose that. No, but now I'm touching it, so you talk about it. What did we have? 15%? Yeah.
So what do you think? Just kind of feeling it? Any differences?
This one is a lot softer than that one.
Okay, it's a lot softer. Okay. So, and you can almost see the yolk a bit more, can't you?
You can.
Okay. All right. So why don't you mass out? So you can just talk about the viscosity. What do you notice? So that was the line. Okay. That was the line where there was fluid, but now look at the line.
So there was more solution, so stuff came out of the egg and kind of like filled up the water a little bit.
Exactly. Okay. And then nice job. And then compare that egg to this one.
A lot more darker in color and probably more like malleable.
Okay. All right. So why would it be darker in color?
More fructose in the water.
Okay. So what happened to our egg? Our egg got smaller, right? This is approximately what the egg size would have been. Okay. So what left?
The shell.
Well, the shell wasn't there to begin with. But what left? Was it water or fructose? Not sure yet. So we're going to look at all the results. Okay. All right. So this one definitely got smaller. All right. So it lost something. But wait a minute. We have more fluid in here. Okay. Is it thicker or still liquidy?
Still liquidy.
Okay. Maybe even more liquidy. All right. So if it's more liquidy, what went in there? Water. So, what left the egg?
Fructose.
If we got more water, so water left the egg, went into here. Okay? So what method of transport happened if it was water?
Osmosis.
Osmosis. Okay, so record your results. Thank you. We want to compare what happened to, what's the after effects? Is it smaller, bigger?
The egg is a little bit smaller, and it has white kind of on the outside.
Okay.
And
Lower this. Yeah, I think the white is just left over from the calcium from the shell. Okay.
And it's really like soggy.
Okay. What about your solution? Because you had 50%?
Yeah.
That's disturbing. That makes me uncomfortable.
50%?
Are you recording?
Yeah.
Hi.
So it's 50% solution. Bring the solution over. Take the cup out of there though, and you can empty the glass into it, the beaker, and you can put that in the off to the side. Perfect. Thank you. Bring it on over. Okay. So what happened? What's in here?
A little bit.
Yeah. So what happened with the fluid? So does it look like it might be thinner or thicker? Thinner. Okay. So if it's thinner, is it more water or more fructose in here?
Water.
More water. So water left the egg and went into the beaker. Okay.
That's why the egg's like soggy.
Yep. So it's much smaller. It's lost quite a bit of water. All right. So what method of transport? Osmosis. Okay. All right. Record your mass thank you. And then what I want, so we're going to compare before and after. You want to talk about that?
Yeah. So this egg is really like, there's no like real water in it. It's very like saggy.
Yeah.
And it dropped 45 grams from the original
Okay, wow.
weight that it was. So it's definitely a big change in size as well. It got a lot smaller.
Okay.
This is very firm. This is
Not so firm.
no. And
Now tell me about the liquid, because this was the
80%.
starting height of the fluid. And look
Really?
how much it increased
Oh yeah. 'Cause
from here to here. Okay, so what went in here? And look at the viscosity. What do we think?
it's like not as thick as it was before.
So does it have more water or more fructose?
More water.
More
So it
water.
took water from the egg.
So what method of transport?
That's osmosis.
Osmosis. Good, right? So if water moved, osmosis.
Yeah.
Right? And so are there transport proteins
No.
for fructose?
Right?
Because if they were, then
Yeah,
fructose
it would have also like big
Excellent.
egg. So
Thank you very much. Tell me, let's compare. So this is what the egg would have looked like to begin with. It's not obviously not the same egg, but it's approximately what it would have looked like before. Now bring that egg on over and tell me what you notice happened to your egg.
It like basically deflated.
Deflated. All right. So what exactly would have left?
The water.
Okay, the water left. How can you tell? Let's take a look at our solution.
Yeah, it's way more watery.
Way more watery. So therefore, if water left the egg, and this is more watery, went into here, what method of transport happened? Osmosis. Are there transport proteins?
No.
No. Okay, thank you very much.
Killed it.
All right. Finished recording all of your data, made your observations and the mass differences. We will then determine the percent change in mass, and then we will be graphing it on this table down here, this graph down here. So I'm going to use the sample calculation in our lab, in the pre-lab calculation. So to determine that, you take the final mass. So in that example, the final mass is 32.1 grams, and always include units, minus, and then the initial mass in that sample calculation is 36.4 grams. Okay, and so once we plug those numbers into our calculator, or simply do that in our heads, we end up with a change in mass of, let's see, we've got 4.3. Okay. Now, we're not going to be graphing change because it simply depends on, our starting and ending. So what we instead do is, it's more important to know the percent change in mass. Whoops. So to calculate that, we would take the mass change, which is 4.3, divided by the initial mass, and that initial mass again was 36.4, okay? And then we multiply that by 100, right? We're determining percentages. Oops, not an equal sign yet, so multiply by 100. And we end up getting, grab my calculator here, so plug that value in, and we have 4.3 divided by 36.4 multiplied by 100, and we get an 11%. Okay. Now remember, just a quick little note, I should have said this earlier, but we just subtracted a larger number from a smaller number, so this value should be negative. You probably already caught that mistake of mine. So this should be negative. So there was a negative percent change, which means that we lost mass, okay? So negatives matter. Negatives tell you you decreased in your mass. So I came out with an negative 11.81, and we'll leave it there. We'll round to the hundredths place. Percent. Okay, so you're going to do that with all of your values, okay? Now, because the first the first beaker with the 100%, 0% fructose, so all water, unfortunately, we were not able to get the mass of that because the egg did break. So one of the things that we did observe beforehand was that egg was very, very full. So there would have been a positive percent mass. So what we're going to do, if we go over to our data table, we're going to be plotting the percent change. So whatever you got for your percentage here, we're going to plot that against the percent concentration of our beakers, okay? So because we messed up with that first egg, what I'm going to do is we know that there was growth, okay, just because the egg was bigger. So I'm just going to kind of do this. So just assume that it was somewhere in here and not make a big deal of it. So from here, because we have a negative, and you're going to notice that in a lot of the other values in your table, you're going to be plotting each point. So for our first concentration, it was 0.15, and I'm just going to go ahead and give you our percent mass change with this one, and our group calculated that to be negative 26.74. So I'm just going to put a little note right here, so I'm going to plug that in, and I'm going to have you continue to do the rest. All right. So once you've got all those points plotted, okay, you're going to grab a straight edge, a ruler, the side of a book, whatever you got. So grab a straight edge, and you're just basically going to try to and include somewhere. So I wouldn't go too high because it wasn't crazy growth, but I would include this. So what I mean is I don't want you to connect each dot that you plot. I'm not going to go ahead and put all the rest of the points, and I'll have you do that. But let's just say you had points like here and here and maybe here, whatever, right? Okay. And it was kind of all over. I don't want you to connect these lines. Instead, what I want you to do is I'm going to have you just draw what's called a trend line. So try to get a line that's sort of reflective of all of those values here. So something like that. Oh, that wasn't very good. So I'm going to undo that one. So something like, all right, so we got one high one here. We got some low ones there. So sort of a line that represents all of them. I could even do a better job. So it's maybe something like that. Okay. And then, so this is what we're after. Most likely it'll probably be a little bit higher than that, but anyway, you get the idea. You just want to kind of have a line, just draw a straight edge line that kind of represents somewhere in the middle of all of those points, and we'll talk about what that means next class. Okay, so that is your homework for today. The other component that I would like for you to do is now simply look at the data analysis and answer the questions on your conclusion component, which is which substance is moving, the water or the sugar, what evidence is there to support your statement, which solutions were hypertonic compared to the egg, what happens to a cell in a hypertonic solution. So what I would like for you to do is answer all of the questions in your data analysis up until you get to the part where it says look at your graph. We will do that together in class. Okay, thank you.